PXRD is a common method to study the crystal structure of solids. Crystalline samples show unique diffraction patterns, used to check phases, lattice structures, and impurities. This happens based on Bragg's law, where X-rays reflect at certain angles from atomic planes in the crystal. In this experiment, we aim to make non-centrosymmetric alpha and beta-2 antimony fluoride glycine and analyze it using PXRD. The crystal shows strong dipole moment and hyperpolarizability from lone pairs and asymmetry. These traits make it a good nonlinear optical material. Though the formula is same, heat causes phase changes, leading to different PXRD patterns. Followings are the reagents. Antimony fluoride and glycine were used without further purification. First, weigh out 0.54 grams of antimony fluoride. Next, we measure 0.11 grams of glycine. Using a micropipette, we add 15 milliliters of distilled water to the mixture. Using a stirring bar, ensure that the reagents dissolve completely in the distilled water. Once the reagents are fully dissolved, we remove the stirring bar. The solution is then left at a temperature above 50 degrees Celsius for 1 day to induce slow evaporation. As the water evaporates, we get alpha antimony fluoride glycine crystals. Use the crystals after washing with hexane. Place the alpha crystals into alumina crucible and put it into the furnace. Before heating, we have to set the furnace. By pressing the refresh button, we can check the setting steps. First, set the heating rate to 1 degree Celsius per minute, target temperature to 165 degrees Celsius. Then, set the holding time to 30 minutes. Remaining steps are not used, so press the refresh button to return to the initial screen. To begin heating, press both buttons under the mode setting simultaneously. After the heating process is complete, open the furnace to obtain beta crystals. Here are the microscope images of the two types of crystals. Prepare agate mortar, spatula, microtube, and weighing paper. Using the mortar, grind the alpha crystals into a fine powder. If necessary, use the spatula to scrape the material and ensure a uniform fine powder. Transfer the powder into a microtube. Repeat the same procedure for the beta crystals. Ensure that the sample volume is at least 0.1 milliliters. Press the run button to power on the chiller. Pour the sample into the center of the holder. Press gently with slide glass to flatten the surface of the powder sample. Ensure that the surface of the powder is flat. Prepare the other sample in this same way. Press the equipment's door lock button and wait for a beep sound to open the door. When you open the door, the following window appears on your computer screen. Carefully put each holder to the desired number position of the sample changer. Close the door and press the door lock button again. Run the MiniFlex guide program in the computer. If the tube voltage and current are marked hyphen, click the startup button in the upper left corner. Assign XG set as hold and click execute to turn on the X-ray. Hardware control window appears in the upper left corner. You can see the tube voltage and current rising. After 7 minutes, check the default values of 40 kV, 15 mA and click the OK button. Click General Measurement on the left. Next, click the checkboxes according to the number of samples to be measured. Click the navigation button to select the folder where the file will be saved, and enter the file name. Set each sample according to the position where it was previously placed on the sample changer. Click the Set Measurement Conditions button to configure the measurement conditions. After setting the basic conditions as described, click OK. Then, press the Run button to start the measurement. After the measurement, press the door lock button, open the door, and retrieve the sample. Then, close the door and press door lock again. Dispose or store the sample as needed, and rinse the holder with water. Then, clean the holder thoroughly using ethanol. Do not use acetone, as it may dissolve the adhesive on the holder. After ensuring that no solvent remains, wipe it clean and return it to its designated place. For PXRD pattern comparison, we use the PDXL software. First, click Load and open the alpha and beta files that you want to compare and analyze. Next, some settings need to be adjusted for proper comparison. Click on the Profile Properties button displayed on the screen. In Profile Properties, select the beta file and set the Y-axis to 10,000. Then, click the Phase Data View button. This allows us to compare the differences in PXRD patterns between the alpha and beta phases of 2-antimony fluoride glycine. During heating, phase transition from the alpha to beta phase occurs. As a result, the orientation of glycine molecules changes, and a less densely packed structure is formed. According to Bragg's law, when the interplanar spacing d increases, the Bragg diffraction angle theta decreases, causing the diffraction peaks to appear at lower 2 theta positions. In the beta phase, the d spacing increases, leading to peaks being observed at relatively lower 2 theta values. Also, since the overall crystal structure has changed, we can observe further differences in the PXRD pattern.